Hi guys. I recently saw this problem in a YouTube short, and the work through was overly complicated and contained a mistake. So I thought it would be a nice little example just to illustrate the power of Numatican notation. I'll link to the original YouTube short in the notes so you can see for yourself. But before we tackle the problem, let's quickly discuss Numatican notation within this context. Now let's take the product relationship between three numbers. So for example, 2 times 3 equals 6 can be written in three different relationship ways. So that's one. The second might be 6 per 2, per just means divided by, equals 3, and 6 per 3 equals 2. So that's three different ways of describing the product relationship between three numbers. And we could also, incidentally, we could reciprocate both sides as well here. So we could have 3 over 6 equals 1 over 2. So that's just the reciprocal of both sides of this equation. So that's the product relationship. And now let's look at the exponential relationship. If we have, again, three numbers, let's take, say, 2 to the power 3 equals 8. Then we can express that relationship in three ways. That's the first way. The second way might be 8 root 3 equals 2. Now remember, this is in Numatican, we write, so exponentials are split into two types. It's either a power, so 2 power 3, or a root, 8 root 3. And in fact, a root is a reciprocal of a power. So to root a third is the same as 2 to the power 3, or 8 power a third is the same as 8 root 3. Now, the third way to express this relationship is using a logarithm. And the way we write logarithms in Numatican is log 2 of 8 equals 3. And the way we can think about that is 2 to the power what equals 8, or 8 root what equals 2. So 2 power what is equal to 8. 2 power what is equals 8. 8 root what is equal to 2. 8 root what is equal to 2. We can also reciprocate both sides of that, and you get log 8 of 2 equals 1 over 3. So again, you just swap the top and the bottom on both sides, because of course 3 is 3 over 1. Okay, so let's go back to our original problem here. Now, I'll rewrite it again. 8 to the x plus 8 to the x equals 4. Now, I mean, anybody beyond kind of infant mathematics should be able to see immediately that something plus something is two somethings. So I'm not going to write this down because we want to do maths in our head, not on the page. The page keeps the place, but the maths happens in our head. So when I look at this, I see 2 times 8 to the x equals 4. And 4, of course, is 2 times 2. So the next line, you could write 8 to the x equals 2. That logically follows. And now we have the exponential relationship in front of us. And I'm just going to write this here. So those three numbers, you've got the 2, the 8, and the x. So like 8 to the what is 2, 2 root what is 8. Of course, there's a L sign in there missing and an equals. Now, okay, so let's write this in the logarithmic form. So the 2 moves up there, the x goes there. So we get log 8 of 2 equals what? Now, if you can't think of 8 to the power of what is 2, or 2 root what is 8, it might be easier to reciprocate both sides, and we get log 2 of 8 equals 1 over x. So then we can write 2 to the power what is 8? Well, 2, 4, 8. That's 3. So 2 to the power 3 is 8. So we can say 3 equals 1 over x. And you can manipulate this however you want. But in my mind, if you've got a single term on both sides of an equation, you can move them diagonally. So the 3 can move down diagonally and the x can move up diagonally. So then you just get x equals 1 over 3. And that's our answer.